This video will be a brief introduction to compound inequalities. We're going to just sort of talk about what these things mean and how to think about them before we do the algebra with them in class next time. A compound inequality is when you take two different inequalities and put them together with either the word and or the word or. Now these words work the same in compound inequalities as they do in just the English language. One of them requires you to be doing two different things, and one of them is sort of a choice between two different things. So let's look at using the word and. An example of using the word and in a regular English sentence is Julie is a member of the Spanish club and the soccer team. That means that Julie is doing two different things. There are some people at MND who are just members of the Spanish club, and there are some people who are just on the soccer team, and Julie is one of the few people who is doing both of these things. The word and requires both things to be true. The other option is the word or. An example of this is next year she will enroll at the University of Cincinnati or Xavier University. Now, obviously, she can't do both of those things at the same time. She can't attend two different colleges at the same time. She has to choose one or the other. Only one of those things will be true. But as long as she goes to one of those two places, then this statement as a whole is true. Next year, she will enroll at UC or XU. Now let's see what it looks like when we put the word and in between two inequalities. So here we have x is greater than -1 and x is less than or equal to 4. Now first let's look at what these things look like on their own. So for example, if I want to graph x is greater than -1, here's what that looks like. I'm going to have an open circle at -1. And all the numbers greater than -1, well, that's the numbers in this direction. Now let's look at the other option. If I want to graph x is less than or equal to 4, well, I'm going to have a filled-in circle at 4. And less than is this direction. Now, what I just drew here is not what the graph of this compound inequality looks like. This compound inequality is saying both of these two things have to be true. It's like when you're in two different clubs. So we have numbers way out in this area that are in fact greater than -1, but are not less than or equal to 4. And we have numbers way out here that are less than 4, but are not greater than -1. And so this is like the people who are in Spanish club, but not the soccer team. These are the people who are on the soccer team, but not in Spanish club. We're only interested in where those two things overlap. We need both of these things to be true in order to have the word and in between. So we're going to cut this off right here and right here. We're only interested in the parts where they overlap, the parts where both of these inequalities are true. So the way I would actually graph the solution to this one is to have an open circle at -1, a filled-in circle at 4, and then shade everything in between. So truly what this is saying is we're interested in the numbers that are in between -1 and 4, including 4, not including -1. And there's another way to write that algebraically. So let's take a look at that. In order to rewrite this algebraically, we want to flip things around so that all of our inequality symbols are less than symbols. So everything is pointing to the left. So we can always go from left to right, smallest to biggest. -1 is smaller than x. X is smaller than or equal to 4. These are all less than symbols. And then as long as we've done that, we can kind of just mash these together. And here's what that looks like. And then we only have to write the x once. And this is literally indicating x is in between these two numbers. So we can rewrite and inequality mashed together like this so that it shows up like an in-between situation, because that's truly what we have here. We're not so much interested in the red line. We're not so much interested in the blue line. We're just interested in the in-between situation where the red line and the blue line overlapped. And that is in between the -1 and the 4. And we can still look for these symbols to let us know if we need open circles or filled in circles. Let's look at another example like that. Now this one is already written as the mashed together version. So we're going to read this from the inside out. We're going to start with the x. We're going to say x is greater than or equal to -6, and x is less than -1. So I'm looking at this as its own inequality, and then I'm looking at this as its own inequality. So in other words, this is saying I'm interested in all the numbers that are in between -6 and -1. And here's what that will look like. I'm going to start at -6. This is going to be a filled in circle because of this or equal to piece there. I'm also going to have the other side at -1, and that's going to be an open circle because that one does not have the or equal to piece. I'm going to shade everything in between. These are the numbers that are greater than or equal to -6 and less than -1. Now, if you wanted to split that up as two different inequalities, you could do that. You could just simply rewrite this yellow highlighted portion, -6 less than or equal to x. And that's the same as saying x is greater than or equal to -6, right? And then we put the word and then we just rewrite this blue highlighted portion. X is less than -1. So here's what it looks like as a compound inequality with literally the word and this is what it looks like as our mashed together version of the compound inequality. Now, this is generally preferred in the math world. It's a more clear, visible way to see what's happening. The x is literally in between two numbers. So that's the version that we tend to prefer. Now let's look at compound inequalities with the word or. Now remember, the word or means only one of these two things has to be true. So let's look at what they look like separately. If I want to graph x is greater than or equal to -1, that means I'm starting at -1 with a filled in circle, and I'm going this direction. Greater than or equal to -1, that's all these numbers. The next one is x is less than -6. So I'm going to start with an open circle at -6, and I'm going to go this direction. And you see, these don't overlap. There is no overlapping part this time. But that's okay, because this is the word or. Now, if this said the same inequalities but with the word and, then we would say there is no solution, because there are no numbers that make both of these things true. But as long as we have the word or in there, we're saying you don't have to go to both UC and Xavier. You just have to pick one or the other. Is it possible for one of these two things to be true? Sure. There are a lot of numbers that make one of these two things true. In fact, the only numbers that are not part of the solution are these numbers right in here that never got shaded by either of them. So with or compound inequalities, we're just going to have sort of two different sets on the same number line that are both being shaded. And there's a lot more pieces to the solution because there's a lot of things that are only going to make one of these two things true. Now, as a general rule, when you have an or compound inequality, you put these things on a number line, you're going to have your arrows pointing opposite directions. Now, when you think about that, I want you to think about oars on a boat. So this is like a canoe. I'm a terrible artist, but here's my canoe, or maybe like a kayak. We've got benches in it. Okay, and then we have oars sticking out from that boat that you're going to use to paddle yourself through this lovely blue water. All right, and then I'm just going to write this in here just in case you can't distinguish what it is that I'm drawing. Those are oars on a boat. Or compound inequalities point opposite directions, just like the oars on a boat. And compound inequalities tend to look like this, where maybe you'll have something here and something here, and you're shading the overlap part. So you're shading the piece in between. So if we're talking about and compound inequalities, I want you to, again, think about the water, the beautiful blue ocean. But then the thing that we're drawing here see if you can guess what this is. It's probably going to look a little wonky because I can't find a brown marker in my OneNote anywhere, but we'll start with this. And then we've got some nice green leaves. And maybe you've got like coconuts in here. Here we go. Coconuts on your tree. That's a palm tree. So this whole thing, what I'm trying to draw here, thank you for humoring me, is an island. Keyword and. So when you have an and compound inequality, your number line is going to look like an island. When you have an or compound inequality, your number line is going to look like oars on a boat, most of the time. Now, there are a couple of exceptions to that, and the exceptions tend to be when the answer might be all real numbers or no solution. So you got to watch out for those things, just like we always talk about, don't totally go into autopilot. But this is sort of what you can expect from compound inequalities.